Okay, good evening, ladies and gentlemen. It's nice to get to talk about gliding in the midst of the winter. Let me give you a little bit of background on how we got to giving this presentation. It's a two-part thing, but originally Eric reached out to Phil Gatesford and myself and asked us if we could give some pointers on how to use Top Hat for the GBSC members that are doing Condor, because a number of them have got the option to connect a PDA or a smartphone to their Condor. And of course, once we started talking about that, the features started creeping, and we turned this into a much larger presentation about more soaring computers in general. So you're going to see on the slides here, it's got US team content. Phil and I are both former members of the US team, and part of our obligation to the US team is to promote the sport and to some degree do fundraising for the US team. So if you watch this, expect us to harangue you for support in the future. But today, what I'm going to do is give you a market overview of flight computers in general, talk about some criteria for picking which one suits you the best, look at more detailed qualification of those computers, and then do a comparison of some of the products in the marketplace. So that'll give you some insight into which device is probably best suited to your application. But then I'm going to go into some practical considerations of using them for glides and looking at when to believe the information coming out of them, when to take it with a pinch of salt. We're also going to give you some tips on computers and the surrounded technologies in general. Last of all, I'm going to show you what I would buy if I was to buy something today for my next glider. At the end of that, we'll take questions and answers. I would encourage you to ask questions as we go through. Just type them up in the chat to Eric, and then he'll interrupt me. Phil's going to be on the mic also during this session, and in the next hour session, he's going to talk about the actual configuring of Top Hat for various competition tasks. I'm going to talk about some high-level philosophies of how to configure flight computers such that you don't end up perpetually confused, which I've done on some of my previous flights. But anyway, let's get going. So here we go. So there are numerous flight computers out there in the marketplace, and some are touching on $10,000 in total cost. Others are absolutely free if you have an appropriate smartphone. So let me try and give you some segmentation of that. So you can load Top Hat, XeSoar, I think iGlide's free too, onto various smartphones and iPhones and use them as they come. They're probably going to be using GPS altitude and in that base format. They will do a reasonable job, and that's something that's wholly appropriate for club gliders. You can also hook these guys up to your Vario, so it gets proper altitude data into them, and maybe even some proper wind information into them. That makes them a lot more useful if you're doing something other than flying a two-seater around the patch. And then there are integrated solutions, and I've got the picture at the bottom left here is one of an UDI, which comes as a box. It's a Windows C device that is integrated with its battery and sits on a sort of RAM mount in your cockpit. And then smaller than that, you can get some small flight recorders these days that have a pretty ridiculous sort of 1.5 by 2 inch screen on the top of them. And some people attempt to use them. My eyes aren't any good for that anymore. But then you get turnkey systems which start with small Varios that have some limited capability for navigation, and then there are, which, you know, less than $2,000 usually. And then mid-range computers are around about $3,000 or $4,000. And then some large, very capable computers that have a lot of functionality, and getting onto 7 or 8 inch screens. So there's a lot of choices out there in the marketplace. And here you've got some pictures. So the bottom right is an LX 9070, which is probably the most expensive and leading flight computer right now. And the one that has Rockton 58 on it is Top-Hat, running on my Samsung S10, which works very, very well in the daytime. So now let's think about, how would you pick between some of these computers? I think there are a lot of factors weigh into this. So the type of soaring that you're doing, if you're occasionally going to fly a club single-seater and do local soaring, you're probably not going to want to spend $10,000 on a flight computer, and it won't be very portable either. If you're going to be doing, mile cross-country flying in club gliders or in your own glider, you may have different requirements to how accurate you want the things to be compared to if you're going to do regional or national competitions. And of course, if you're going to buy a new glider, you probably want to put something that's going to go into that glider that will last for some number of years. I have 2 systems in my glider, and the one that's glued into the panel I use as a primary navigation device. And upon a little RAM mount, I have my Samsung S10 with Top-Hat running as a backup. Now, when I'm locally flying, sometimes I program the S10 with Top-Hat, and sometimes I don't. But it's there should I need it. I also look at what is the lifespan. The lifespan of any smartphone type device is going to be a couple of years before the battery gets problematic, and they've taken enough wear and tear that they're no longer reliable. The touchscreen gets dodgy, etc. When you buy an integrated system, they generally last 10 years or more. I think I had one in a previous glider for 15 years, and it was still working fine at the end of it. Something which pains me to admit it is my eyes are deteriorating over time. And when I was in my 20s, I couldn't understand why anyone would ever put anything bigger than a 2 1/4 inch instrument into a glider panel. And I'm better side of 60. I'm looking at the big instruments and much preferring them. I have a small, fully integrated LX Navigation Zeus computer, and it uses 8-point normal width fonts for many of the things in it. I just can't see it properly in the daylight with my sunglasses on, so I don't use that at all. Yeah, I bought it as a backup, and it would take a really awkward situation for me to dust it off and put it in my glider. Some other things to think about are, how tidy do you want your cockpit to be? When you get some of these smartphone solutions, you may have GPS cables and power cables and other things dangling across your cockpit. If you spend a little bit more time, you can use Bluetooth and make them look a little tidier. But my S10, I'm running in the glider without the USB power supply plugged in. It probably goes for about 2 hours because you have to turn the brightness up way high to negate the impact of the sunglasses. As I said earlier, these things come from zero costs for a smartphone solution, going up to $10,000 for the really large ones. An interesting facet is that if you're flying here on the East Coast or in Europe, you're probably spending most of your time below 5,000 feet. And you are very rarely going to notice any true airspeed factors. However, if you go fly out in the Rockies or Nevada, you're going to be spending most of your time over 10,000 feet, and the true airspeed becomes quite a factor. Now, not all of the instruments do a good job of that, so it's something, where you're going to spend your time flying it can have an impact on it. So I'm going to go through some nuts and bolts of some of these things, and feel free to pipe up with any questions. But the readability of most of these instruments is pretty poor until you get up to this number, 1,200 nits. The latest generation Samsung phones actually have 1,200 nit displays, which are equivalent to my ClearNav and the LX9000 series devices. So they can work in bright sunlight. However, I turn them all up fully when I'm flying, because I find that with my sunglasses on, they're nowhere near as bright as I want them to be unless they're turned up fully. So if you're looking at a particular PDA, e-reader, or a smartphone, and it says sunlight readable and it's got 600 nits, it's probably not going to work that great in the glider. Some people use Kobos, and I have a couple of Kobos at home, which have black and white displays, and they have fabulous contrast. But I was using one of the pre-worlds in Lithuania, and they have a lot more complex airspace in Europe than we do here, and it gets quite problematic to sort out the different types of airspace when they're all done with different cross-hatching of particular polygon. So I after doing that once, I thought I'd go and find something that was a color solution. Now, accuracy is quite important. If you're flying around locally and you aim to get back to the airport at 1,000 feet, and you have a 500-foot margin on your glides back to the airport, if you have some inaccuracy in the glide computer, it's not that critical. When I'm gliding back, I tend to glide back with a lot less margin than that. So it's common for me to throw a 300-foot margin in and set off. I add more if I'm coming over terrain like Wachusett Mountain, but so I have a need for the glide data to be a lot more accurate than less accurate, because I'm tending to push it down towards the limits of the aircraft. If you're not doing that, you can get away with a lot more margin. Something that not many people understand is that when you put a lot of GPS antennas in the panel, they can interfere with each other. And my teammate in Czech Republic, Eric Nelson, went the whole way through the contest with one of his computers, the GPS coming and going all the way through the contest. And subsequently, we did some messing around with the antennas and got that to go away. But there are things that you've got to be careful of, with respect to the accuracy. In racing, the Germans teach all their pilots, vents open for the start, vents closed for the finish. And there's a good reason for that, because it's worth about 200 feet. So, be cognizant of that too. The wind information, I put on the slide here that you need pitot and static and good GPS to calculate really accurate wind. That's true up to a point. if you want dynamic accurate wind, you need all that data. If you like on your flight logs, you look at the circling over a period of time, you can get a good approximation of the wind without that other data. But the circling wind is delayed a couple of minutes. So if you're going through wind shears, it's better to have more data fed into the computer and calculate an accurate wind. So of course, if you're using a simple smartphone, you're not going to get accurate wind. If you have it connected up to a vario of some sort that does wind calculation, which is not just a dumb vario, then you're going to be much better off with respect to having accurate wind and its impact on the glide home. Where the real-time wind really helps you is when it's changing. So if you're flying in the mountains and you drop down below the top of the peaks into the valleys, quite often the valley winds are significantly different to the upper winds, and you really need to know that. Now I'll stop here and give you a good story. Well, this was about 20 years ago. I was did a flight up to Sugarbush from Stirling down to North Adams, and then came back. And at North Adams, I bumped into Harvey Howell, who back then was flying, I think it was an LS4. And we both climbed up on the high ground just to the east of the airport to something approaching 10,000 feet. And there was a great wind from probably cloud base 25 knots from the west. So our computers said that we had it made with a couple of thousand feet to spare. And I set off gingerly, and Harvey set off full of enthusiasm. And it was sort of working well until we crossed the Connecticut River, when Harvey was flying about 15 knots faster than I was. And as you drop down through the wind, it decreased as you drop down below 7,000 feet. It went from 25 knot tailwind to about 15, and it continued to happen as you went further down. So the end of the story is Harvey ended up landing 10 miles short. So having that dynamic wind as you come down through the wind gradient is sometimes very, very helpful, and it can prompt you to ratchet back. If your glide computer is only using circling wind, it's not going to have, it's going to tell you you're falling off the glide, but you're not going to get a good indication of why. It's probably apparent to most of you that if you're using an open source product, you're going to get user group support, and if you have an expensive vario that you've paid someone to build, then they're going to have a support desk that will help you with issues. Although I must confess, I've had a lot of luck sending stuff to Europe and getting it repaired, but if you need a quick turn on an instrument, it's best to buy it manufactured in the country where you are, because you can get it turned around in a week. Whereas if you send one to Europe, you're going to be out for a month, which necessitates you having a spare one of some sort. I'm a particular fan of having instruments that have knobs on them for glider flying. I found touch screens are okay most of the time, completely worthless if you're flying on a ridge or if it's really, really turbulent. I've done some competitions in Pennsylvania on the ridges flying out of Mifflin County, and the first one I did was with a touchscreen device. I think it was an iPac something or other, probably 15 years ago, and it was a real drama to change the McCready setting on it when you were on the ridge, because you were bouncing around so badly. There's a couple of things that are counterintuitive. I've got down here, keep it simple, stupid. And what I found with many computers is the more options you have, the more difficult it is to get on top of it. So if you look at the pictures on this screen, on the left is a ClearNav Glide computer, and that is the only flying screen. So you can toddle on some numbers on the bottom, but that's a pretty common configuration there, and that's what you see all the time you're flying. Every number's in the same place, and that's it. In the middle, I've got my top hat configuration where I have 5 different screens. And you'll see I've got one for circling, cruising, starting, a FLARM radar one, and then one for more details on airspace. I don't think I would ever need more than that, but that's, you know, a significant difference from the ClearNav where you have the one screen. Then over on the right-hand side, you'll see 19 screens. So this is I can't remember whose, but maybe Adam Woolley's original 9070 configuration. It's got 19 screens. So you see there's a huge difference between a ClearNav and LX 9070, and I find myself with the 9070s hunting and pecking something, whereas on the ClearNav it's right there all the time, and it's much easier to find stuff on the top hat. So, you know, when you're thinking about flight computer, if you're not going to be using it for particularly demanding flight tasks, then simpler is probably better, in my opinion.
Excuse me, Bob, we had a question. Do you happen to know what the nits value is on the OD2?
I don't know. My guess is that the ODs are somewhere in between 600 and 1200. But that's just from looking at them. I haven't looked up the specs.
Thank you.
Now let's do some comparisons here. For the open source instruments, I've picked XC Soar and Top Hat. Now, Top Hat is a US skin on top of XC Soar. So the software underneath is very similar, and the functionality is very similar. It's just the user interface is different between the two of them. And Top Hat, you have to go out of the flying screens to get a lot of the things that are hidden away in XC Soar. They're both good products, and I've seen people choose between them based on their like or dislike of being constrained on the Top Hat user interface. So Top Hat constrains how you jump between turn points, and you flick left and right. And some people like that, and some people don't. If you don't, then you're going to use XC Soar probably. But XC Soar has lots of features. It has lots of hardware support. Top Hat is easy to install on Kobos and things that can download Top Hat through the Google Store. XC Soar has the ability to be loaded onto a lot of more fringe hardware. They both have issues, I think, with the density altitude calculations. I've noticed huge disparities between what my ClearNav and my LX Nav's final glides say on what comes out of the XC Soar and Top Hat when I'm out in the Rockies. I spent some time talking to Dave Nadler about that, and he was flying with Top Hat also, and he said almost certainly they got some errors, or they haven't implemented density altitude, probably because most of the people doing the software development for that are in the lowlands of Europe. the thing that I really like about Top Hat is that on the flying screens, you've got virtually everything you need. You've got 8 boxes that you can pre-program to give you various pieces of data, but changing the turn points, clicking on things to do a glide to a particular location are all very easily achieved. Unfortunately, the thing has been mothballed now for about 3 years. Rob Dunning, who wrote it, moved on from gliding, and no one's picked it up. So if any of you are avid software developers with time on your hands, it would be great if you picked it up and merged and brought in the latest features from XC-Soar. Some of the things that would be really advantageous to get into a later version of Top Hat would be the SkySight integration and perhaps weather radar integration. Those are things that are starting to become increasingly important. Now, the commercial solutions, I'm going to look at high-end ones and low-end ones. So the ClearNav Vario is a really, really good Vario. It's probably the best Vario I've flown with, and has a really intuitive thermal helper. And I found the wind to be particularly accurate also. But it's it's a 2 1/4 inch instrument with a navigation head on it, but it does relatively straightforward navigation. It doesn't do complex competition tasks. And the ClearNav computer is simple to use, but its software has been archived for longer than the Top Hat software. So I've seen no new features come into that, well, significant features come into that in about 5 years, which is starting to be a challenge as the other instruments are continually evolving. On the LXNav side of things, and LXNav and LX Navigation generally have equivalent products. There's a lot of cross-pollination between the 2 development teams, and I think they all used to work for the same person about 20 years ago. So the LXNav S100 is a good entry-level system. It fits into a 3 1/8 instrument, gives you a lot of capabilities, although when you're doing a lot of the navigation, the details of on the screen are quite small. The LX 9070 is a premium device with many more features than you're going to see in like the S100. It's got a huge screen, and it has a ever-increasing list of hardware options, so you can plug onto it things like a flap lever transducer, so it can calculate whether you're in the right flap position as you're cruising along, for whatever wing loading you are at whatever height, and it can help you with things like that. The other thing that's happening with the 9070 is it's getting lots of new features every year. So last year it had the weather radar and the SkySight integration added to it. And I use SkySight for planning all my flights, and it's sometimes I think on a blue day it would be really nice to have where SkySight thought the blue streets were going to be on the moving map, and you can actually get that on the LX 9070. So if you have the money to spare, you certainly get a lot of value from that instrument. Like I said, the downside is it takes quite a long time to get used to it. So that's covered the instruments. So like I say, if I flip back to the beginning here for all the various options, you get what you pay for. So if you're flying around the club in the K21 on a nice soaring day, you can use your smartphone and it'll get you home. But if you're going off to race in the nationals, you probably want something that's more on the right-hand side of the screen here, that's going to give you some more accurate glide information, more accurate wind information, a much larger visual of where you are relative to the task or the terrain or whatever it happens to be, perhaps even the weather forecast if you've got SkySight up on there. So, you decide what your application is and decide what your budget is and take your pick. Is there any questions on the instruments before I talk about some of the common sense usage?
I think that was the only one about the Yodi so far.
Okay. All of these instruments have the ability to add margins and arrival heights of various degrees to each of the places that you want to glide to. So normally when you're programming one of these and controlling the glide, you're going to glide to a start line, a finish line, a turn point, an airport, or a land point. And usually for the start line, you need to be below it. For the finish line, you need to be above it. For the turn points, that's just a reference to how high you're going to be above it. May make sense if it's a mountain turn point to know exactly how high you're going to be above the ground. Airports and land points are things where you're going to be gliding to them from some distance, and quite often makes sense to get there above the ground, not to get there at 10 feet. So, how should you use the instruments to the best effect? Well, I've tried a lot of different things over the years, and the thing that I like the best is to set zero margin against whatever it is I'm gliding to. So it's consistent. If I'm gliding to the start line, it's the height I'm above or below it. If I'm gliding to the finish line, it's the height I'm above or below it. When I'm gliding back to the airport, it's the height I'm going to arrive above it or below it. So I don't have to do any math. And let me tell you why I think that's important. I was flying in the national championships out in Hobbs, New Mexico. And that was some years ago when I had my SW24, I think, with an SN10. And I think I had a moving map top hat with it. And we had a really, really long, hard day with thunderstorms. And, it was within 20, 25 miles of getting back to the finish line. It was already 7 o'clock, and I was scrambling around and not climbing up. Ultimately, I looked at the land points in my SN10, and I was about 5 miles from Lovington Airport, and it said it was 200 feet low. And as it happened, I was over this really nice field, so I landed in it. It was a bit of a field because it was a pea field that they just hoed, and you sank in about 10 inches into the soft dirt, so getting out of there was a challenge. But after we got out of the field and went to the local Church's Fried Chicken for dinner, I started thinking about what had happened, and I was really quite vexed with myself because I realized that the land points in the SN10 had a mandatory 150-meter extra height, and I could have got to the end of the runway at Lovington with 150 feet to spare, and it was a really long runway. It was 5,000 feet long, so it may even have been, by the time you factor in the glide computers, you put the middle of the runway, probably could have got there with 250 feet to spare. So I landed in a field by the fact that at the end of the day, when I was really tired, having had a harrowing last hour, all below 1,500 feet, I didn't have the emotional energy left to do all those calculations on what the margins were. So ever since then, I've been particularly fastidious about removing margins, and in that glide situation, the number I see on the screen is the number I'm going to deal with. So that's something you really need to be thoughtful about, because it's not when you're having a calm day that it'll bite you. It's when you're stressed, when the glides aren't working out, when you've been flying for 5 or more hours and the sun's starting to go down. That's when you need to pay particular attention. So I always like to have no margin in there. The number I see on the screen is what I'm going to get. Any questions on that?
I don't see any yet.
All right, very good. Another thing to bear in mind is glide calculations in the computer assume that you're going to go through as much sink as lift. And depending how you fly the glider, that may or may not work well. Over the long haul on a pretty homogeneous day, it probably will work. But usually you're using the glide computer for the last 30 to 60 miles. And usually between where you are and the airport that you set off from. And if you look at the glide computer and point straight at the airport, it's very, very likely that you're not going to get there, even though the computer says you will. Because there are going to be, if there's wind, there's going to be some sorts of streets, clouds lining up. If there are lines of hills, they're going to kick off lines of lift downwind of the hills. If you if you look at the diagram here, the recommended flight path is to fly along the streets, cut across them, and move, not to do the diagonal. You can guarantee that if you fly the purple trajectory on this particular soaring day, that you're going to be a couple of thousand feet low when you get to your destination. And if you do the green one, you'll probably be a couple of thousand feet high. So even though the computer is telling you you've got the height, you've got to still fly in a sensible direction to achieve that. You can't just barrel across the sky without paying any attention to where the lift is and where the sink is, and where the mountains are. Are you upwind or downwind of mountains, or if there's a wave over the top? You've got to pay attention to, are you on the downwind? You're trying to do a final glide through the downwind part of the sky, or the downwind of the wave cloud is going to be sinky. So you don't want to do that. You want to be on the upwind side of the wave clouds if you're doing your glides. So these are all things that you have to factor into the usage of these glide calculators. And if you don't do that, you're almost as good using 5 miles, 1,000 feet, because you're guaranteeing that the information that they're telling you isn't going to be applicable for your day. None of this is said in the manuals, of course. All right. As you saw earlier, a lot of the glide computers have almost an infinite capability to make them configurable. I have tried that in the past where every particular type of screen, and I generally use the start, circling, cruising, FLARM, and airspace as my 5 go-to screens. When using an LX nav box, they have a different cadence where they have land points, air points, tasks, and then a whole slew of different screens popping off the bottom and going off to the side in that particular matrix. I go back. If you see here, these airport mode, waypoint mode, and task mode. Those are the 3 columns, and you can put lots of different screens in those columns. And when you're flying, you're going to, most of the time you're racing, you're going to be in task mode. When you're doing cross-country flying, you could be in waypoint mode, where you're going to a waypoint, but you haven't got a task programmed. And in airport mode, you're generally going to somewhere where you're going to land pretty soon. So that's all focused on gliding to a particular landing point. And you'll see they have, each of these modes has different screens associated with it. What I've found is that when I'm flying, I like things to be really, really simple. So I don't tend to do the LX nav 19 screens, although I could do something similar to that in the top hat. What I tend to do is these consolidated screens, and with the exception of the start screen, I tend to have all the buttons the same on all of them. You say, well, why is that? Well, if I want to know whether I'm above the final glide or not, I know where to look, and it's always in the same place. If I want to know how much time is left in my 4-hour task, it's always in the same place, staring me in the face. So you'll see here that the 4 screens on the right are all basically identical for what's in the info boxes, which is these little squares. And the only thing that's different is, in the start one, where I'm managing something that is orthogonal to cross-country flying. So you're managing how long have you been below the start height, because in the US rules, there's a necessity to be below the start height for 2 minutes before you start. And there's a pretty officious penalty if you mismanage that. So I have a button down there on the bottom right, which tells me how long I've been below the start height. If it's more than 2 minutes, everything is cool. If it's not, I have to be really careful. I have a thing called a Klein Band in there, which is a little graphic that shows you the thermal strength with height, which before the start is a great thing to take a peek at, because it might tell you that there's a wind shear or an inversion somewhere as you're climbing up, and it gives you a clue that later in the task, stay above 3,000 feet or stay below 4,500 feet or whatever it happens to be in the consistent part of the weather. The other thing that I have, if you look at the top right, is the altitude from the barometer, which means I'm reading the data out of my, this one is connected up to the Vario glide computer, and the thing that's generating the IGC flight log is shown here as the barometric altitude on the top right. So if you're getting really close to the the start height, you can look at that, and that's the number that's getting fed into your flight recorder. So that's the one you need to pay attention to, but only at the start. So makes a lot of sense when you've got your device, whatever it happens to be, to program it to be inclusive of all the information that you need, but not to throw superfluous stuff on screens that you're not going to use on a regular basis. One of the things that I like about Top Hat versus XC Soar, if you look at the screen here, you'll see, the finish is 4.5 miles away, and then I've got a glide of 7 feet to it. Well, that's because I'm in my kitchen. But a lot of that information is all there in that polygon with the next turn point in it. So you don't need to use these information boxes to the same extent you would on some other visualizations. In addition to that, there's an above and below glide symbol over there on the left. And it's showing slightly green right now, which is meaning you're just above glide. So that's another key thing from my perspective when you're using these flight computers, is to keep it as simple as possible, such that when you get into duress, you have a go-to location on the screen to get the information you want. You're not having to read these little titles, because every screen's got a different piece of information on it. That's too error prone when you're in a stressful situation. The other thing that I like to do when I'm configuring my Top Hat is to set it up such that the amount of writing on the screen is curtailed. So these are the same screen. You'll see on the right one, we've got lots of airports with their full names all over the moving map. On the left, we just got the 3 letters. If it's a turn point, the numbers identifying them. And if it's an airport, just the first 3 letters. I prefer the one on the left. And the reason I prefer the one on the left is you get some information about the terrain. So when you're soaring, having a good idea of whether it's a wet valley or some high ground is particularly useful when picking your route. You want to go over the high ground with sunny facing slopes, and you're going to get more more thermals off that, and they're going to be stronger than the stuff that's moisture or in the middle of a wet river valley. Excuse me. And you'll see on the screen on the right, it's a lot harder to get that topology information. There's a lot more writing all over the place, and the terrain doesn't jump out at you anywhere near as much. So that's why I tend to turn all this stuff off and get as much of the terrain information on the screen as I can. And there's little of the superfluous, town names, airport names, and all those things. I'll turn them on if I need them, but I tend not to have them up on the screen the whole time. And in my experience, if you don't take advantage of the terrain, you will be needing those airports. If you are careful about where you're flying, you're more than likely not going to need those airports to land at. All right, that's the configuration section. Are there any questions coming through, Eric?
There was a long one, but I think it from Ken Sebasta, but wait till we get to the Q&A.
All right.
So
Okay.
I don't mangle it, or
Yeah.
more straightforward. Just to let you know, it's 7:53. So
Yeah.
we'll run
I'm probably
a little bit
gonna
longer, but
run over a few minutes. But when you get your computer, here are a few tips for putting it in there. Glass fuses are better than the circuit breakers, because you lose a lot of voltage. You get about half a volt drop across a circuit breaker. And you're going to find your radios and various other devices are going to start squawking at you a few hours into a flight if you use the circuit breakers. The batteries, you really need to have fuses right within a couple of inches of the battery terminals to be safe and avoid fires, because you know, just having them on the panel end, you could get a short somewhere and have the wiring catch fire between the battery boxes and the instrument panel, and that's a really bad day. The lithium-ion batteries are really, really good. I've had some for 5 years. I really enjoy them. If you buy them, get the ones with the battery managers included with them. And lastly, with respect to batteries, I use X series connectors. These are the audio, usually 3-pin audio connectors that, you know, bands use for their microphones and their, you know, electric guitars and whatever. And they're good for 10,000 insertions, which means you're never going to get there in the glider, and your batteries are always going to be connected. I see a lot of people using these little white Molex connectors that quite often are supplied by the glider manufacturers, but if you ever take the time and read the spec on them, they're good for 300 insertions. So basically after 5 years, you've got to take them out, throw them away. So it's better to get something that will last the duration. On the wires, Teflon wires are better than the PVC ones. If you do have a short, the PVC ones will melt and catch fire. It becomes a drama. Something that I do to save my batteries is I have these mechanical indicating switches for the main and standby power. And if I leave it on, you can see, you know, it's orange. So it's sort of screaming at you not to leave the battery on. I've still done it once in a while, but far less than a regular toggle switch. The other things that are important are the tubing. If you use the medical silicone tubing, it's going to last many, many years. If you use the PVC tubing, you can usually get it about 5 years before it gets really stiff and is prone to leaking. If you like mechanical varios and electronic varios, it's safest to put a Y connector in the total energy tube at the back of the seat pan so they don't interfere with each other. SN10 seems to work happily with a Winter. The latest ClearNav vario is not very happy with a Winter plumbed directly into the same total energy. The LX Nav doesn't seem to like it much either. What happens is the Winter is a flow instrument, and a lot of the modern electrical varios are pressure driven. So, you know, the fact that you're moving the needle on the Winter is having a big impact, secondary impact on the pressure coming from the total energy tube. So it causes it to be nowhere near as accurate as if you separate the two. And ideally, you take 2 separate feeds from the total energy tube at the tail, but that's a drama to do. But you know, separating them at the back of the cockpit is a good compromise. I've done that on my last couple of gliders. When you're connecting up to speakers, I like to have the speaker pointing at me. If you look at my recent glider, I've got the speaker on the instrument panel at the bottom pointing right at me. So I don't have to have it up at 100 decibels to hear it against the other noise in the cockpit. I really like that. And the last thing is I use the Delphi 8-pole connectors to make the panel easy connect. Those Delphi connectors are the sort of thing you see on your car. They tend to be really robust and reliable. I don't worry about the waterproofing aspects. Just they tend to be a nice connector. And in full disclosure, I used to work for Cambridge Instruments, and they evolved into ClearNav, and so you know I know a lot more about ClearNav than some other instruments. So you know, and you know, I particularly like the ClearNav vario. But what I fly with today, and that's on the left is the picture of my panel. I have a LXNav, I think they call it an S7 now. It was a V7 when I bought it, which is an integrated Vario and glide computer. I have a ClearNav Vario, a ClearNav navigation display, which is that little square thing you see on the left, a ClearNav navigator in the middle, and then I have Top Hat running on that. That's on the Cobra. I've evolved that to a Samsung S10 recently, but that's the sort of stuff that I have in my panel. If I was, and this panel is 2012, so it's 9 years old. If I was to buy something today, I would probably get something that's closer to what you see on the right-hand side, which is a 9070 big LX nav that has the ability to have the weather radar and the sky side in it. I would probably also have the ClearNav Vario again. The audio is much better than the audio on the LX nav Varios. I don't know why. The needles, on my current panel, I've got both the ClearNav and the LX nav Varios next to each other, and the needles are absolutely identical in all situations. But the audio is easier to comprehend on the ClearNav, and I think they're doing some clever gust filtering on there so the audio doesn't bounce, and it's much easier for my ears to understand what's going on. So I would probably keep that Vario, and then a lot of the other things that you see on this right-hand side, I would have as we, as we get into, more and more into ADSB land, I think it's going to be increasingly important to have an ADSB transponder in your glider, just so you can go everywhere that you want to go rather than be constrained. But that's it. I'll take questions at this point. Barry, do you want to open up the mic and see if we can get some, because it seems that people seem reticent to type in questions, and I completely understand that.
Yeah. Actually, if you look at the chat, there was one from Ken Sebasta. You happen to be there, Ken? If you can unmute, start with you.
I am here. So thanks a lot for this. This is great. My question kind of goes back to maybe before this seminar even started, which is kind of why are we doing this? Why do we have a glide computer? What questions do glide computers answer? And the reason I ask that is because when you open up XCSOAR or when you open up Top Hat, there's no guidance down to the point of not even having a map to show you where you are. And so configuration winds up being challenging, to say the least. And I think it'd be great to sort of understand what questions are we looking to answer so that we kind of figure out how to start navigating these programs, because I'm sure they become secondhand after time is spent with them. And I'm sure a lot of the user interface decisions make a lot of sense, especially taking into account things like trying to navigate a touchscreen and a bumpy interface. But it'd be wonderful, and maybe it's outside the scope of this conversation, but it'd be wonderful to actually go back and start with why are we asking these questions and examples of how different interfaces can help us answer some of the more common questions that all glider pilots have. Yeah,
well, it's relatively straightforward. I'll take a shot at it. Back when I started, there were no computers. And to figure out where you were, you had a map and you looked out the window and you put your finger on the map if it was a hazy day and kept it on the place that you were last at, so that then you could look down and figure out where you were going. And we had very mechanical glide calculators that were like a whiz wheel type of a device. So the glide computers, satisfy a need for spatial awareness. So where are you currently? And that's not only relative to the ground and the geographic location, but also to the airspace. So where are you in the three-dimensional world? And then where can you go to if you need to go there? So, from this place, 3,300 feet, over the Garden of VOR, where can you go to? So it answers that question. So where you are and where you can go to. And then layered on top of that is, if you have a particular task, whether it be a silver distance or a gold distance or your first competition task, it gives you the information on how to get to the various turn points on that task and how to get back. And at an even higher level, it'll tell you, when do I need to start to actually achieve that distance with the thermal strength that you've programmed in for the day. So on a 3-knot day, how long is it going to take me to do a 250-kilometer flight? They'll give you that sort of information. So they give you spatial awareness, navigation capabilities for tasks and cross-country flights, and then a strategic planning capabilities. Is this thing that I've put in my computer at all possible? And if you program in maybe the cloud base and the thermal strength, it'll say, okay, this particular length task you can do in X hours, and then you can look at the SkySight forecast for the day, and do you have those X hours before it all dies? So those are the puzzles that it's helping you answer, and you can do them manually. And we used to do them manually. It's just a lot easier and a lot more accurate to have the computer do them for you. Did that help?
It does. It does. It makes me more puzzled about why systems such as XCSOR and Top Hat don't instantly provide that as the default interface, because that certainly has been my experience. I learned to fly before GPSs, and now they're Dynon, G1000s, etc. LX navs. They're very good about presenting this information immediately, but that's clearly not all systems, and so it leaves a neophyte such as myself scratching my head about what is it that what is it that is the goal?
Yeah.
To have so much complexity at my fingertips.
Yeah. Well,
so there's a key question I think you left out, Bob, and that is, the reason we developed the B100 originally, and which led to the SN10, and that the key question is optimizing your speed from where you are now to finish the task. So for competition use, a key issue that your glide computer helps you with is, how do I get to the finish line fastest? And some of that comes from playing with the thermal activity, and some of it comes from being more efficient on deciding you can glide home. But that was the big question we tried to answer when we developed what was probably the first flight computer for gliders.
Yep. That makes sense. And it also prepares you if you can't get home, right? So you're looking for somewhere to land if you're going to run out of day before you get home. Do we have other questions?
Bob, can I make a comment?
Sure.
A couple of times you've referred to the LX 950 and the 980 and the 970. For the people who aren't that familiar, it might be helpful to know that all of the LX 9000 series computers are essentially the same hardware and software. The only difference being the physical size of the unit. The 950 is smaller than standard. The 970 is larger screen than standard. The 980 is an integrated Vario and moving map screen, but they're all basically the same unit, and they use the same software, and the software is interchangeable. So I thought people might find that helpful.
Yeah. There's one other thing, Roy, that I learned the hard way. There are versions of software that fit in the whole LX platform, and they've done something which is clever and frustrating. They've abstracted the user interface into almost infinitely configurable graphical user interface, and you use a styler to pick all the stuff you want on the screen.
Yep.
And it can, as Roy said, it can be on the small, medium, and large display. It can also be on the one that fits in, I think it's the 8080 that fits in a 3 1/8 inch hole, but it's really all compressed down to small icons when it's in that format. But the thing that they don't publish well is that the certain capabilities in that software and that user interface evolution came in with different variants of hardware. So in Czech Republic, I think I had an older LX9000. Eric had a new, brand new 9070, and we could get the team codes and the direction to your teammate to work on his, but it wouldn't work on mine. And so you have to be a little careful if you're not buying a brand new LX to make sure that the features that you're going to try and utilize are supported by the hardware.
Yeah, the second observation I had is fairly simple, but it's important. If you're using two batteries and you're changing in flight between the two batteries, it's very important to have a system that allows you to go from battery A to battery A and B, and then battery B. If you use a rotary switch, none of these computers will tolerate even a microsecond of being non-powered. Yeah. And they all crash if you use a rotary switch.
Yeah, that's a great point, Roy. And we've got the pictures here. If you guys look, if you can see where my mouse is now, there's the main switch on my panel. Next to it is standby, and next to that is the tail battery. So if I'm losing my main battery, I push the standby on at the same time. Then I've got both main and standby on, and then I release the main, and I've swapped from main to standby without restarting all the computers.
Yeah.
On the standard Schleicher panel, which is what you see on the right side here, they have a rotary switch, which anyone that's got an electrical engineering degree immediately takes the wire cutters to and cuts it out and does something different.
That's right. I got rid of the rotary switch on mine, the first order of business.
Yeah. I mean, they do it because they've got so many things on the panel that, you know, it consumes a lot of space to do anything other than that. You'll see on my panel here with all the fuses, the meter, and the various switches, and then I got 2 USB feeds for various auxiliary instruments. You know, I've lost basically 2 instrument holes down there to switches and fuses.
And Bob, I don't know if you can hear me. Of course, there's also the option to use Schottky diodes, right? And have all the batteries connected. That way the Schottkys prevent that the batteries are discharging each other. The price that you pay is about half a voltage of drop if you use the Schottkys.
Yeah, I tried those on my solar cells, and they didn't work for some reason. Didn't work very well anyway. The key thing with that half a volt drop is after 3 or 4 hours, you're going to get your radio complaining about low voltage.
Yeah, I agree.
And that's on this, my recent glider, you know, I paid the 2,000 euros for the solar panels because I was sick of the batteries running out. What I find now is that with one lithium-ion battery and the solar cells running, I can run the big transponder and the the ClearNav display for 6 hours, and towards the end of the 6 hours, it's getting a little soft, but you know, it does a pretty good job. Without the solar cells, if I ran those together, I would get about 2.5 hours, and I'd have to punch it into the standby battery,
Mm.
which didn't give me enough margin if you got stuck somewhere and you had a 7-hour flight.
Maybe to that point, you saw me during the seminar. I posted a couple of pointers there. So I'm like Eckbert. I'm from Germany, so the accent will give it away. Hi Ken, good evening.
All right.
So
Hi.
my buddies in Germany just were able to root the first color e-ink device. So our Kobos, gray and white, can now be replaced with color. And they are experimenting with this, and there is a supercharged mode where it's fairly fluent, right? So that is something to look into. So LX8000 runs on that, and XE Soar as well. Onyx spoke to color, I've posted that. And secondly, you had a really nice slide that showed on the left side the cell phone-based Android devices, on the right side the super expensive ones.
Yeah,
you probably know that. Yeah, there is one in the middle, and I don't get promotional support here, but one of our kids there, Stefan Langer, he's one of the juniors that has Stehfly Aero, and he sells the XC Soar on an open platform, and for about 600 euros, you can buy XC Soar, and it looks like an LX9000. So for us, the price point is super for all the club ships, and certainly for the first-time glider owners. If you're gutsy enough, you can solder the board yourself. If you don't, you pay $50 extra, and somebody will prepare the entire kit for you.
Yeah, I really included that on the left side with, this is an UDI, but I bought a hang glider instrument, which was a Kobo with a big battery pack in a molded plastic cover. And it had a pressure transducer and a GPS stuck on the top of it. So it was a fully integrated system with a battery. And I think it was like $600, something like that. But that's the same concept. There's, some people have integrated the, the open source software with some sort of a hardware, inexpensive hardware implementation, and you can run with it. It's a great point. The other thing is, if you are adventurous and have a weekend, you can take a Bluetooth transmitter and solder it into the back of a Kobo. I did that. So the thing is about let's say 1 centimeter by 1.5 centimeters, and there are 4 connectors. So there's 2 power connectors and a transmit and receive. And there's a place in the back of the Kobo you can solder the wires onto, and put some hot glue in there, and then you've just got to fuss with the with some of the software configuration of the Android. And I did that, and I have the Kobo that you see on my glider here. This one, you don't see any wires connecting it in because it's Bluetooth.
Very nice.
Yeah, and there's, if you go on the XC Soar, user group, there's a couple of pages in there that tell you how to do it. It's very, very useful.
Yeah.
Yeah.
And the other thing, I like this question that came up, ADSB in, right, and in Glide computers that can process this. So I'm very interested in that myself, and no matter how I looked at it, it appears we have to throw money against this. So of course I have my 4Flight brick there, but the Glide computers do not use that proprietary system, so I cannot use this. The kids in Europe are now converting over to this Flam Fusion, which is about $1,800. Which is good for us here in the US as well. It does ADSB and transponder code, so with that, and Flam, so with that we should be all good. But again, I need a $1,800 brick in order to then bring that signal into the cockpit.
Yeah, I have a power Flam hidden away behind the panel here. On the left side, you can just see the antenna poking up at the top, which does, the power Flam has ADSB and Flam signals. When I look at my Flam radar, I get both power
and I believe with this Flam Fusion, for the first time, we are wiping away the borders between the US and Europe, because I understand that Flam Europe runs on a different signal than we do here in the US, and Flam Fusion apparently works worldwide.
Yeah, I mean, all they've done is they've made the radio part of that a software-defined radio as opposed to having it be hardware. So it's, when the powerful arm, the new one comes up, it figures out which continent it's on and loads the right software for the radio frequencies of that
very
continent.
cool. And then last announcement from my end, you guys are probably aware there is a tectonic shift happening in Europe right now. We are abandoning OLC. So for some weird reason, there were politics involved. The guy that maintained OLC, I don't know what the reasons were, and some really bright kids in the universities have brought up weglide.org. Weglide.org is now the platform for us Germans for the DMST and the OLC. So you will not, most likely not see any Germans posting on OLC anymore. That thing is dead.
That's interesting. I hadn't heard that, but thanks for sharing.
Yeah, anytime. Weglide.org.
Yeah, I'll check it out.
Yeah,
I suspect OLC will have some momentum here.
yeah, this is David Sherrill. I tried out WeGlide this weekend because it was featured on the Thermal podcast recently, and it really does have a lot of nice features in it. And you can take your entire logbook of IGC files and drop them on it for a single upload. You do have to click on every single one quickly to acknowledge that the start and end times are computed correctly, but it adds statistics, it adds tasking, it does a lot more than the OLC. Plus, it'll show you dozens of flights in your area. I hope other people will load it up, because right now I seem to be the only flight showing up in New England.
Yeah. Well, thanks for sharing about WeGlide. Is there anything else that's topical in Europe?
No, that's pretty much it.
Yeah.
We'll keep you posted.
Yeah. Okay.
Cool. And by the way, for some shameless self-promotion, so with Egbert, Ken, and myself, you have 3 AC5M rushers in a 50 nautical mile radius. I don't think there is a larger density of AC5M rusher self-launch gliders than here in New England.
Don't forget Rob Spencer. Oh, sorry. Don't forget Rob Spencer at Concord. You know, another.
Oh, that's right. 4, yes. And I should also say, I know that Ken is a very so Ken is trying to convert this into electric, and this is a project that we are all looking forward to. So this is really cool stuff. If you have not seen Ken's hangar, you wanna bring the camping chair and the popcorn.
Okay. Cool. All right. Do we have any other questions?
I have a question about environmentals. So having put up a whole bunch of 42-inch ink screens all over Boston, I've learned that they really don't like hot and they really don't like cold. And then I've heard stories about people's systems shutting down due to overheating direct sunlight. And I'm curious what the group has. You know, what's the consensus on hardware which is resistant to the temperature extremes we see, and what are mitigation strategies when we have hardware we like that's not compatible on its own?
Yeah, I can give you a long story about Kobos, because Phil Gaisford and I bought a bunch of Kobos that we were going to use in Lithuania, I think, when we did the Worlds there. And it turns out that the touch screen is quite finicky, and it seems to depend on the actual unit. But we ultimately ended up buying a load of bezels that tried to shield the sensors, which are along the side of the screen, from the infrared in the sky. And they worked a little bit, but they were not the total solution. So what we found with the Kobos is it generally run for 2 or 3 hours and then lock up, and you have to restart it. And sometimes it wouldn't restart, and most of the time it would. And like I said, it particularly didn't like getting hot, as well as really bright sunlight coming in at a fairly acute angle against the. If you look at the screen on the left here, you've got the Kobo there, and the sensors are along the bezel, and they, you know, if you're flying with the sun on either wingtip, it tends to shine in at those pickups and screw up the software. So I think, you know, when they did the testing of the software for that device, they didn't put it in extreme lighting environments. So it was very easy for when it got something it didn't understand from a touchscreen perspective to go off and execute some software that, you know, wound it into a knot. Other than that, the Kobos have been pretty good. The various other handhelds that I've used over the years, none of them like it if you leave the canopy closed on the grid with the without a canopy cover on it. So once you're in the air, they don't get so hot. But even the commercial instruments like the ClearNav and the LX9000s, if you leave them on in the cockpit with the no canopy cover, you can get it so the screens go funky, and then you've got to cool them down.
Have people experimented or had success with heat sinks or other active cooling methods?
I think there's not been a need at providing, you know, you're up in the air. I mean, when you're in the air, there's enough airflow in the cockpit that the thing doesn't get to, you know, 40 degrees anymore. When you're on the ground and the whole thing's in the sun and the canopy's closed, then the temperature goes way above 40 centigrade, and then they become a problem. But it's just a matter. Yeah, I've seen people put a small towel over the top of the, you know, the flight computer if it's on a RAM mount, just to keep it out of the sun while they're doing something. But, you know, I haven't seen any need for active cooling.
One comment about something that was said a little while ago. I would be very cautious about connecting two batteries to each other without electrical protection. And I would be extremely cautious if the two batteries were lithiums. If they're at different states of charge, that is one of the things that has the potential to cause a fire. It's not something that I would play around with.
Yeah, totally agree. Totally agree.
Yeah, but that's why you'd have fuses, right?
No, the fuses don't help, Bob, because the batteries are trying to feed each other, and the currents that can get you to a fire are not beyond the normal discharge currents of the batteries that the fuses would not protect against. That's why they put shotkeys in that was mentioned earlier. It's not. I mean, the problem is it'll likely be fine, and short exposures are likely to be fine. The problem is that the downside is really, really bad.
It's also just horribly inefficient. To charging any of these lithium battery chemistries is about 70% efficient. So if you
well, no, that's not the issue. What Bob's talking about is connecting the second battery while the first one is still connected for a short period of time.
Well, I think he specifically outlined to get one with a built-in power management system, which would protect against specifically that, but it would wind up recharging the lower battery from the higher voltage battery, which would be inefficient to it.
Yeah, that's immaterial because you're not really planning to leave it on in that configuration for very long.
Well, if you're just like
switching from one battery to the other.
Honestly, excuse me, guys. It's coming up on 8:30, so we're getting a little off the topic of the flight computers and such. I would ask that, you know, if there's any more questions for Bob, feel free to ask, and then we'll sort of wrap up for the night. No, going once, going twice.
Yeah. Okay, so let me line you all up for next week. Next week, Phil's going to do the talking, and he's going to talk about how do you configure and use Top Hat for cross-country and early competition flying. So he's going to tell you how to use it and get value out of it rather than what it is, and compare it against other commercial instruments.